Okay, question 15. So we're going to be doing a similar sort of thing as before, and we want to find the internal force for BC. This is getting on to exam level. Okay, so we can't directly do method of joints at B. We have to work there. So we have to get there by going from joint A to joint B. So what I'm thinking for this problem, it would be a good place to pause the video now and try and work it out at that point, or pause the video whenever you feel comfortable that you think you can work out what the internal force is BC. So I'm gonna go for it, and you choose basically when you want to pause the video. So the starting point is to find the reaction at A. So what we're going to do is we want to find this reaction RA. So what's the easiest way to do that? Well, it'd be to take moments around G. Okay. So we can see that the 120 is going to be 12 meters away from G. If we take this to be clockwise, you can see that my 120 is pointing the opposite direction to my arrow there. So that would be a negative moment. And the RA force is going upwards, and that's 18 meters away. So that's going to be a positive moment. Rearrange that, use your calculator, and then you're going to get the reaction at A is going to be 80 kilonewtons. So at that point, do you think that's a good point that you could then work out what BC is? Or do you have to show you a bit more? So the next thing is I will then find the internal force in AB. Why am I doing that? Because I'm creeping up on this member here, this BC member. So that's an unknown, and that's an unknown, and that's an unknown. So what I'm going to do is find this value here, and then this member here will become a known. So that's my plan. So previously I found that that's an 80, and then I noticed that this is actually a 3, 4, 5 triangle. So 3, I'm going to split the 6 in 2. 4 is the height, and these cross members therefore are going to be 5 meters. Or I've changed color. Well, I'm a ballpoint. Okay. So we know we're dealing with 3, 4, 5 triangles. So we know what our cos theta is going to be here. In this particular case, cos theta will be 3/5, and the sine theta will be 4/5. So we done all the analysis on the terms of geography and geometry that we need. So let's deal with the problem now. So we've got 80. We're going to take that acute angle there to be theta. And we know that we've got AB going off in that direction. And we've got an AC going off in that direction. Should really close my circle in them, really. Okay, so we are going to do method joints at A. So we'll do that by resolving upwards. So that will pick out only AB. So AB to point upwards has to be times by a sine theta. The 80 is already pointing upwards. So we just need to rearrange this equation here to find what AB is going to be. So AB is going to be minus 80 divided by sine theta. So AB will be minus 80. What's sine theta? Well, we've worked that out previously. That's the 4/5. So that then gives me minus 100 kilonewtons. So I tell the reader that's in compression. Okay, now for the bombshell, we are ready to solve what BC is. So we previously found the AT. We previously found that AB is minus 100. We're going to make AB point the opposite direction because we're now looking at joint B. So we put a big circle around joint B and look at the forces that are inside there. There's going to be the BC force, which is the one we're looking for, and the BD force, which is one we're not bothered with. Then we have to say to ourselves, which direction shall I resolve forces so that I can pick out BC? Well, I want to do method of joints at B, and it makes sense to resolve forces downwards. Everything's vaguely pointing downwards. The AB is pointing downwards, the BC is pointing downwards. I could then look at the geometry here and look at whatever this acute angle is. This, I'd call it gamma. And I notice that when I resolve forces going downwards, that I will then have AB swinging through cos gamma, and then I'd have BC swinging through cos gamma. So actually, I don't really need to even work out what cos gamma is, because I can see that they're going to cancel. So that then just gives me that that BC is going to be equal to minus AB. Well, I previously found what AB is. That's minus 100. So that tells me the answer is going to be minus 100. So that tells me the answer will be plus 100 kilonewtons, and that will be in tension. Okay. So I lied. I threw in a bonus question at the end. That's if you're really keen. Have the bonus one and just watch me solve it.